right, today we're going to deal with restriction maps. So now you understand what a restriction enzyme is. It cuts. There's going to be an application from this. It's going to come together today and even more so next week. We're going to use your textbook for this lesson, okay? So what you're going to need to assemble is you're going to have to get your textbook. I suggest getting a pencil, maybe a pen, 2 different color pencils. I'm going to be color coding a little bit. Maybe a roll of masking tape, okay? Something to draw a circle with. If you care to draw a perfect circle, you don't have to draw a perfect circle. That's just my suggestion for you. So, and then open up to page 369 in your textbook. All right. So, we're looking at restriction maps. So yesterday I showed you how to draw restriction enzymes, how they're cut, okay? And if you want to read your textbook, there is some extra information here on page 366 to 369. It goes over what I taught you yesterday. If you'd like to read it, it's there for you. It certainly won't hurt you, but I'm not assigning it. All right, restriction maps are maps that show us where these restriction enzymes cut, okay? And so what I said to you yesterday is if we're going to put restriction enzymes into some DNA, ideally we want to throw a few different species into that mix, because the more species you have, so we have EcoR1 here, we've got Hindi3, the more species that you throw into the mix, the more cuts that are made. The more cuts that are made, the more places you can insert the genes, right? Does that make sense? You can add more genes in here. And then there are other applications that we'll get to next week. So when a geneticist wants to insert a gene and wants to see if the digest is working properly, what it does is it makes a restriction map. And so this is a prediction of where, when you throw EcoR1 into your DNA mix and you throw Hindi3 into your DNA mix, where the cuts should be made. So in other words, where those recognition sites are. So I'm going to say something right now, okay? And if you were taking a note, you would write this down and highlight it. But somewhere I suggest you do write this down. It's really important before we go forward that you understand that each of these different species has a different recognition site. So in other words, EcoR1 is going to cut in a different place than Hindi3 is going to cut. Okay, so I'll say that one more time. Each species has a different recognition site and therefore will make cuts in different areas or locations of the plasmid. Okay? So this explains some of that, and what we're going to do is go right into this tutorial. So I'm going to work through a few of these with you, and then I'm going to give you an assignment to hand in for an application mark. So we're looking at page 370 right now, okay? And they give us sample problem 1. So what you want to do is draw your plasmids out. So for on page 370, we are working on sample number 1, problem 1. Okay, and so I have 2 restriction maps here, and I'll show you what we're going to do with them. So get those drawn. You can pause my video. All right, what you need to do now is you have to look at this. So if we have plasmid X is the plasmid, okay? So this signifies plasmid X, this signifies plasmid X. All right, you'll see in a few minutes why I'm drawing 2. Plasmid X consists of 1,400 base pairs. Okay, so they're telling us that. We will always have to tell you that. If this was a real test, if this was a regular semester 2, I would have to give you this information and you would be challenged to do these maps on your own without any help. Okay, after I taught you them, obviously. Things are modified. You can look things up. You can talk to each other. You guys are probably have a separate post where you're posting your answers before you do anything. We are well aware of that. But in order to be true to yourself, you have to make sure that you understand this, okay? So you can certainly ask somebody else for the answers, but if you think you're going into this subject area, it's not going to help you to cheat. You have to be able to solve this problem on your own. So 1,400 base pairs for the plasmid, okay? When we put EcoR1, this bacteria, it looks for its recognition site, GAATTC, it looks for that, and it only finds it once in this whole plasmid. And so it makes a cut. Okay, it'll make a cut, and it'll only make one cut. So however many fragments are listed under here, that tells you how many cuts this organism makes. So EcoR1 makes, in this particular plasmid, it only has one recognition site, it makes one cut. Okay, when we put BAMHI in here, or HH1 in here, BAMH1 makes 2 cuts. okay? One that consists of 600 base pairs, one that consists of 800 base pairs. And then here's the thing that makes it just a little bit more difficult. When we have EcoR1 and BAMH1 in the same mix, so we're throwing two different species onto the same plasmid, there are going to be 3 cuts made, okay? And so your job and my job is to make the map and say, okay, this is where EcoR1 is cutting, this is where BAMH1 is cutting. And so that's our task. So let's start with these maps now, okay? And I'll keep this in front of me, and I'll be referring back and forth. So I'm going to see if I can just bring this up a little. Of course I can. All right, and so that's probably, hopefully a bit more helpful. Honestly, under the document reader, I would be going back and forth and you'd be getting dizzy just the same. So you have this in front of you, okay? I'm going to have it in front of me, but I won't be showing it to you right now. We're going to be working with this map. So we know that when we make a cut with EcoR1, okay, so what we're going to do is we know that this indicates one cut. This whole thing is 1400 base pairs. When we make a cut with EcoR1, I'll indicate EcoR1 in purple. EcoR1 cuts, and it makes only one cut, and when it cuts, it has a fragment that is 1400 base pairs long. Okay, so I'll draw that in. You don't have to draw it this way, but I find it helps students to understand that from here to here, we've got a cut that is 1400 base pairs long. One cut. Okay, one cut. This whole thing is 1400 base pairs, so if it cuts, it would straighten out into 1400 base pairs. Now, we have another map for BAMH1. Okay, so BAMH1 I'll just do in pencil. So we've got BAMH1 cutting, and how many cuts does it make? It makes 2. How do you know that? It's in the table on page 370 under BAMH1. It makes a cut at 600, that leaves a fragment length of 600 base pairs and one of 800 base pairs. So we indicate our cuts indicating the species. So BAMH1, okay, makes a cut there, and it finds its other recognition site over here. And so when it cuts, it makes a cut of 600 base pairs and 800 base pairs. Now, I know you're saying, back it up a little bit. Many of you are saying, what is she doing? This whole circle represents 1400 base pairs, okay? So what our job is to identify an approximate length that would represent 600 base pairs and 800 base pairs. So in other words, from here to here, we have 600 base pairs, and from here to here, we have 800 base pairs. So what am I doing? I'm eyeballing it. I'm saying, okay, I know this whole thing is 1400. This is 1400. Okay, I've got to cut so that I've got a 600 and an 800. All right. So when we put these two together, and that's what our job is, okay, we have to make a cut. We have to show that we've got these cuts now. Okay, so very easy on their own. We've done this map and we've done this map. Our job is to amalgamate the two maps and put them together and show that we've got a 100, a 600, and a 700. So this is very easy, and I'm going to keep it quite easy this semester, to be very honest with you. We have to show that we've got all these cuts. So how can you make, knowing that you've got a 600 and 800, how can you make a cut that's 100, 600, and 700? The easiest way to do it, guys, is the obvious way. We're going to cut this section that has 800 base pairs into a 1 and a 700, okay? So in other words, we're back on this map. We're going to work, you have to choose which map you're going to work with. I've already made more cuts on this map, so we're going to amalgamate them onto this one. And so we know that we have to make 600 is good because we end up with 600. We have an 800, so we have to cut, and we can make a cut right here on the plasmid, okay? And this cut indicates EcoR1, okay? And when EcoR1 cuts, we get another cut where we have 100 and 700 base pairs, okay? So now what you do when you check this, especially as if it would get more difficult, you would say, you have to check and you have to say, okay, do I have, well, you don't have to say okay, you have to say, do I have a 100 fragment? Okay, so I'm going to be going back and forth here. Yes, I do. I've got a 100. Okay. Do I have a fragment that's 600 base pairs in length? Yes, I do. Okay, right there. Do I have a fragment that's 700 base pairs in length? Yes, I do. Okay. Have I stayed true to my original BAM HI that had to have 600? Yes, because between BAM H1 and BAM H1, I've got 600. Did I stay true to my fragment length of 800 between BAM H1 and BAM H1? Yes. And here's the final checker. Do I have a fragment length digested with EcoR1 that's 1400 base pairs long? Yes, I do. Because I've only cut once with EcoR1. Okay, only one cut. So we know the plasmid is 1400 base pairs. So if I go from here to here, I get 1400 base pairs. Okay, I know for some of you this is going to be very difficult. It's a real spatial thing. It's difficult when I'm teaching it live. Okay, when you're in front of me, I get probably, I'd say 10 to 25% of the people that just don't get it. All right, so I hope that's not the case. It makes it even more difficult now when I'm at distance learning. But the benefit here is that you can replay this video over and over again. You can't replay me in class over and over again. All right, so that's one. I'm going to do 3 with you. If you find that this is becoming easy, you shut me off, okay? So let's try the next one here, this practice problem here. So draw your fragments, or I'm sorry, draw your plasmids, okay? And I'm going to go a little bit more quickly on this one, okay? So this here is going to represent, we have EcoR1, okay, super quick. EcoR1 cuts, we get a 600 and a 1200 fragment. BAM-HI cuts in a different location because it's a different species, and it looks like it's the same, right? And this is where some of you, the 10 to 25% of you, are going to get tricked. These are not the same cuts. Remember what I said at the beginning of the lesson. These are different cuts, different species, different recognition site from yesterday. We looked at one recognition site for EcoR1. It's GAA-TTC. But BAM-HI does not have that recognition site. It's going to cut at a different location. If you want to know its recognition site, look it up. Okay, but that might even help you to believe what I'm saying. So BAM-HI comes along and it cuts a plasmid. It cuts it with 600 base pairs and 1200 base pairs. These are not the same cuts. When we put these cuts together with these cuts, we get 4 cuts. And this is our job, is to make this map, staying true to this and to this. Okay, and I know the answer is on in the textbook, but I've learned from teaching that's not going to be good enough for you. Okay, so we're doing this together. Now, we can do our EcoR1. Okay, so we've got EcoR1. I'm using pencil. For EcoR1, you don't have to. This whole thing is 1800 base pairs. How do I know? 600 plus 1200 equals 1800. They didn't tell us that this time. Okay, we just have to know that. So if this is all 1800, we're going to eyeball it and say EcoR1 makes a cut that's about 1/3 the size, and that's going to be, always label this EcoR1, that's your species that's made that cut. 600 base pairs there, 1200 base pairs here. Okay, is that looking like that? No. So what am I saying to you? Did I do that really well spatially? This doesn't look like 1/3 and that looks like 2/3, so I'm going to move mine up a little bit. Okay, and I'm going to say that's EcoR1. That looks more like 1/3 to 2/3, okay? All right, now that's EcoR1 done. Let's do BAM-HI. All right, so BAM-HI, I'm sorry, I call it BAM-HI, it's BAM-H1, okay? BAM-H1 makes a cut and makes another cut. I know it's looking like I'm making the same cuts. I'm not, because I have to put the 2 of these guys on one map. That's BAM-H1. So BAM-H1 has a cut of 600 base pairs, and BAM-H1 has a cut that results in another fragment of 1200 base pairs. All right? So we have to put these 2 together. So I'm going to work with this map. It doesn't matter which map you're going to work with, but obviously you're going to choose this one because that's what I'm doing and that's what I'm helping you with. So we have 600, 1200, 600, 1200, but what we have to end up with when we put the 2 together are cuts that result in 200 base pairs, 200 base pairs, 400, and 1,000. So again, easiest way to say this, to do this, and it's honestly the easiest thing to do, is just to say, okay, I have to get from this map that I'm working with, this plasmid, I have to make sure that I get 1,000 and 200. Okay, what am I going to do? I'm going to splice my 1,200 and my 200, or my 1,200 up into a 200 section and a 1,000 section. Okay, so let's do that. We have to cut this into 1,200 and 200 and 1,000. So I'm going to do that. So I'm going to say that this is 200, and who's cutting? EcoR1 is cutting, because we've already got BAM H1 on there. So this is an EcoR1 cut. And EcoR1 results in 200 base pairs and 1,000 base pairs. Okay, so we're going to have a 1,000 base pairs. So we're getting our 1,000 here. We're cutting the 1,200 up into 200 and 1,000. All right, we have to make another cut. And we have to say, okay, I've got 600, I've dealt with this and this, now I can deal with 200 and 400. 600 divides easily into 200 and 400. That's going to be what I'm going to do. Okay, so we've got 600, and we're going to divide it up into 200 and 400. All right, so your guess is pretty much as good as mine, but some of you guys are going to do a little bit better. And I'm going to make my cut here. Okay, so I'm going to say that this is 400. I'm cutting my 600 into 400 and 200. And who's cutting? EcoR1. Now, you might not always get this right the first time, because you might think this, and this is completely okay to think. I'm going to cut my 600. We know that this is 600 labeled purple. I'm going to cut it into 200 here and 400 here. Okay, when you do your check, which I'm going to do in a moment, you'll realize that it's incorrect, and you would have to switch this line. So obviously my brain is obviously wanting me to put that line in there right away. You might want to put that in here, and you'll realize how that's incorrect in a minute when we check. So now we have to check and make sure that we've done this correctly. Do we have 200 cuts do we have two cuts that allow us to have 200 base pairs in length? Yes, we do. Here's a 200 from here to here. Here's a 200 from here to here. Okay. Do we have a 400? Yes, we do. Between BAM HI and EcoR1, we have a 400. Do we have a cut that's 1,000 base pairs in length? Yes, we do, because BAM HI is cutting here and EcoR1 is cutting here. And that's giving us 1,000 base pairs. Okay, so from here to here, right from here to here, we have 1,000 base pairs. Okay, okay, and I'm going to go to the next thing. All right, so now we have to make sure that we've saved the integrity, I like to call it, of BAM H1. Is there a section of BAM H1 that you can identify still that's 600 and 1,200? Well, for sure there's going to be, because we went with the BAM H1 map. So BAM H1 from here to here is 600. Okay, we've kept that. This cut to this cut is 600, and this cut to this cut is 1,200. Okay, already labeled in purple over here. All right, now this is the hard part. Do you have an EcoR1 cut that is 600 and 1,200 between the EcoR1 incisions? So we label EcoR1 here. Okay, this is 200 plus 400. That gives us our 600. Okay, 200 plus 400 gives us our 600. And so now, hopefully that's an aha moment for you. You couldn't cut with EcoR1 here because you wouldn't get a fragment length of 600. If you would have put your cut here, that would have only given you a fragment length of, I'm not sure right now because I'm thinking backwards, but it wouldn't have worked. Okay, and then do we have a fragment length of 1,200 between our EcoR1s? So we've got a 200 plus 1,000, right? Because we are going from here to here, right? And that's 200, but we have to go all the way around to the next EcoR1 cut. That EcoR1 is 1,000 base pairs long. So we have our EcoR1 from here to here is 2 plus 1,000 gives us our 1,200 cut. Okay, So EcoR1 to EcoR1 is 1200, and so we've done everything correctly. All right, I'm going to go on just to the next one. If you get this, you can stop. If you want to try this now, this is what I'm going to ask you to do actually. Try practice question 1, all right? And then you can come back and see how I've done it. So pause the video. Okay, you're coming back from your pause. I am drawing restriction maps, or I'm drawing plasmids, sorry. Okay, and this is page 372. This is number 1, and this is the third and final example that I'll show you. Okay, so you were trying this on your own entirely. Now you're going to see how correct you are. So plasmid Z is 1500 base pairs long. Okay, when we cut with EcoR1, we make our EcoR1. Remember to indicate who's cutting. EcoR1 divides this into thirds again. So we're going to have EcoR1. EcoR1 doesn't always divide into thirds, so forget the again in that sentence if it confuses you. But we have 500 here and 1000 base pairs here. Okay? Now, when we cut with PST1, we cut and we only get one cut. So PST1 makes a cut, and it makes a cut at, sometimes they're going to show it to you like this, 0 and 1500 base pairs. Okay, so what you want to know is from here to here, all the way around, it only makes one cut, and we have 1500 base pairs. All right, so amalgamate your two maps however you'd like. What you have to say is, I have a 1500 base pair, and then once I put both species together, I get a 300 base pair length, 500 and 700. So what's the easiest thing to do? I'll work with this guy here because I've already got two cuts made, and I need to divide my 1000 into a 300 and a 700. So we're going to say that this is 300 and this is 700, okay, base pairs. And who cut this? It's PST1, okay? So now your question, some of you are going to say, could I have cut it here? Yes, because this is only making one cut. To be completely honest, if you cut it here, you would still have the right answer. So if you divided this into 700 and 300 up here, that would be completely correct. How would you know? It's when you go back and you do the check that I'm going to do now. Okay, so when we have both species in the digest, we have a 300, a 500, and a 700. Do you have a 300 base pair length? You do. Okay, that's good. Do we have a base pair length of 500? We certainly do over here. Do we have a base pair length of 700? We do from PST1 to EcoR1. Remember, these two species are actually making these cuts, so you would actually have them made, and that's why we have to check and make sure that they're there. Now, have we preserved the integrity of PST1? In other words, has PST1 made only one cut, and is it 1500 base pairs in length? Absolutely. So going around here to here, we would have 1500 base pairs. Okay, and that's why if you cut it there, you would have done the same thing. You'd say, okay, from here to here, I'd have 1500 base pairs. And then, do I have a cut between EcoR1 that is 500 base pairs? Yes, I do. Do I have a cut between my EcoR1s that is a 1000? Yes, I do. Done correctly. Okay, so what you're going to do for me is you're going to hand in this assignment, all right? And it's page 49C in your booklets. I'm only asking you to do 1 and 2. Please don't ask in the group chat for a copy of this answer, okay? I mean, I know if you're struggling, you're desperate, but I would like you to truly understand this on your own. This is going to give you your application mark for the unit. Okay, so this is going to be an application mark. I'm going to have it due Monday at 11:30 p.m. So that gives you today, it gives you the entire weekend depending on your schedule, and it gives you Monday. Of course, on Monday, I'm going to come back with another lesson okay? And there's going to be more work, but it does allow you that freedom of getting it done when your laptops are available, that you can actually give this to me, okay? But the beauty is that you are printing it off and putting it onto paper, okay? And you can work with it that way when the rest of your family might be working on your laptop. So you're going to do this now. This is going to put it all together for me, all right? Quick explanation. You are going to make your cuts, okay? So this is telling you where you're going to make your cuts. So they've drawn the plasmid for you. If you would like to draw another plasmid and hand this in a different way, you can do that, but eventually you have to amalgamate the two onto one plasmid. So rough work on another plasmid on another page, and then put your final copy here. That would be my best suggestion. And then just so you know, you are going to be putting these guys on the gel, okay? So there's BAM H1, Hindi 3, and then you're going to put them together. So you can write them down together, BAM HI or BAM H1, and Hindi 3 is going to go in this lane, and you're going to run your gel, okay? So what you're going to do is come up with some markers on here. So what am I saying? You can divide this as though it's a graph and decide where you have to put those. That's part of the application. So seriously, if I get 51 copies all the same, divided exactly the same, then I know everybody's used somebody's copy. Somebody's asked one person or two people in the group. So please try and make up your own score so that at least I know a group of you are thinking together. Okay, not everybody's just relying on 3 or 4 people. All right, and I don't mean to insult you, I just don't want that to happen. So you're going to come up with your numbers here like you did on the gel yesterday. So if I can just find my gel, I'm going to tell you what I'm talking about here. So yesterday we did this, okay? And they gave you these numbers. And so for this assignment, you're going to come up with these numbers here is what I'm saying. Remember, it's negative at this end where you're loading the gel, and this is positive at this end, okay? And then you're going to put your fragments in here for each case. Now, that's it, okay? You're doing that for number 1. You're doing that for number 2, okay? And then you are going to answer these questions additionally, okay? So this is going to give you a good application mark. Obviously, you're not going to have word-for-word answers that are going to be the same as everybody else's. So this is also where I maintain a little bit of integrity in this assignment, okay? So you're going to answer each of these questions. You are able to answer them. I've already given you answers to this, but this one here, I would love it if you would research something that I haven't taught you, something that I might be teaching you next week, okay? So how is this used? This is an application mark, okay? I'm going to say probably, I might forget, but I'm going to give you probably a good 3 marks on that question because I want to see some research there. What is a practical application of this information, of this activity? Okay, how is it used? And don't give me insulin because I've already told you about insulin. So come up with something different, do a little bit of research. All right, good luck, have fun.